Hello, we are Team Gimel with CS326. My name is Ronan Sauls.
I'm Gilbert Horman.
And I'm Jun Nguyen.
And we're here to present our project, Fizzy, the web-based fuzzer visualizer. We'd first like to introduce our project by talking about the login page here, featuring a robust and modernly designed logo stating the name of our project, as well as a basic user login API. Here we have two fields for a username and password and offer the availability to both log in and register for a user profile on our website. We do have basic user authentication, so the very first thing I'm going to do here is try to log in as a user that doesn't exist. I'll simply say foo with password 12345. If I try to log in, we get an alert message saying that this is an invalid credential. In order to do this, we will need to first register a user by clicking the register button with the UI stating we are registered, and then we are able to log in with these credentials. Now that we've logged in, we're faced with the home page and the large bulk of our website. This home page here, let me just delete this save credentials pop-up. This home page here hosts a large bulk of information about projects being actively fuzzed in real time. On the left side of the screen here, we have a basic chat window that will be able to coordinate chat messages amongst different users. To exhibit functionality here, I'm just going to type in the chat box down here and say, hello world. We can press enter to send it, and as we can see, this message is populated on this right-hand pane here with a real timestamp in Eastern Standard Time, as well as the username. Additionally, with respect to the chat function, we have both edit and delete features. To delete a chat message, all you need to do is go up to the little X button underneath the corresponding message, and then it's deleted. Editing has a bit nuance to it, where you type the replaced message you want to say. So for instance, I'll say, hi universe instead of hello world. And then you click the edit button, and then the chat message gets overwritten with the text there. Additionally, here in sort of the center of the screen, we have this central table that stores all currently logged in users. Not logged in, all currently registered users. Our website always features a admin user, which has a few more capabilities compared to a normal one, as well as a table down here at the bottom where you can store information about various different projects you may be working on in real time. So for instance, we could say project name is foo, fuzzer name is fuzzy, and then let's set all of these just to tilde as an example. We can submit this, and as we can see, this table is now populated. And I will refresh this page just to show all of this information is in fact persistent. As we can see, our message is still updated there. This project is still here. Here on the right-hand side of the page is another table that displays various information corresponding to specific details brought to you by whatever fuzzer you're running. We provide information such as total cases, the number of crashes that have achieved so far, how long the server's currently been running for, and as you can see, this is updating in real time. And while these are currently all set to 0 values right now, a little later on in the presentation, we will show you what everything looks like in action so that you can see these videos be updated in real time.
Okay, so that was the dashboards and login pages. So for advanced use, we actually need some kind of features where we actually fuzz it. So the first feature I want to show you is control flow graph. So as you can see here, fuzzing actually we need to investigate each function and how it was run in real time. Here you can see if you click any buttons here, which is function we actually extract from the actual programs, we can see the graph was actually rendered in client side. What's more interesting about this is that in a control flow graph there are some conditional jumps like JAL here, which jump to other functions. If you click on those kind of blocks, you can actually go to other functions as well without indirectly searching inside this list. So for example, I want to go to call exit procs, which actually exists in here. I just select it in the drop down and click go. As you can see, it now turns into call exit procs function and show the graph of it. The second features I want to show you is social assemblies, which is also critical when you're doing fuzzings. It's a second type in navigation bars. As you can see here, it reads from the servers. These are actually deployed and found on the servers. Two files, simpletest.c and simpletest.s, which is corresponding to a source code and the assembly line codes. If you click on it, this will be downloaded from the servers and actually show you and actually highlight the code for you. One additional feature for this is that if you select on a few lines of code and right click, there's a drag a comments button there. If you click on that, it allows you to highlight some comments which noting for future reference. For example, I want to say, okay, check these functions again and set submit. As you can see, a comment was made with the current timestamp. If I actually reload this page and select the files again, you can see that the comment was persisted. And the last but not least, last but not least features I want to show you that is line graph. This is gonna visualize the actual data from aggregate the data from dashboards and show you possible visualizations like how many clicks per time, coverage per time, or initial crash per time. But we don't have that now, but we will show you that part later. As an admin, you also have some kind of privilege in manipulating users in the systems. There's options to manage users here, which allows you to manage admin account and user account. As an admin, you have an option to actually delete the user account by clicking remove here. For now, we are currently logging in as users, so you can see you actually remove it and show it again. It turns out user doesn't have the privilege to do it. Now I will try to log in as an admin. And go to config page again, manage user, and click remove. And at this point, you can see that we actually remove a user account.
Okay, so at this point we have shown all our entire site in a static point of view, but there's a dynamic aspect to it that's much more important. And since this is a website that should be used to visualize fuzzing data, we'll now demonstrate how the website interacts with the fuzzer once it's actually being run. Just to quickly introduce fuzzing, Emery brought it up in a previous lecture. It's basically when you have some program and you send it a bunch of random data and hope that it crashes. In this case, the program will be fuzzing is basically just this, that it's a C program, it takes some input, it checks if some bytes match up to a specific input, and if it does, it just executes an instruction that crashes it. So a fuzzer would run this with random inputs and try to detect a crash. And the purpose of our application is to basically visualize the data the fuzzer generates and display it in a nicely human-readable way for an analyst to make sense of what the fuzzer is doing. So let's now go and actually just run the fuzzer and start looking at the dashboard first of all. We can see that the view on the right is immediately starting to be populated with some information such as the total amount of fuzz cases we have done so far since the fuzzer's run, which in this case is about 10,000 now. So the fuzzer has run the program around 10,000 times now with different inputs, trying to find a crash. It has not yet found the crash, it looks like. It's still at 0 for both of them. The fuzzer's been running for 24 seconds. The coverage it has found is 65 in this case. Coverage denotes pretty much which blocks of the program the fuzzer has explored. So for example, looking back at the source code of the test, the fuzzer would, for example, send back new coverage information whenever it has found a new if branch, and that allows us to get a better understanding of what the fuzzer is doing. And an instructions count that just shows how many instructions the fuzzer has executed. So now in the 45,000 cases it has done, it looks like it has executed about 17 million instructions. And yeah, so that's the first data that's being dynamically updated. We can at this point also look at the line graphs. We can look at the cases per time graph. This, for example, showcases how many fuzz cases per second the fuzzer is doing. So at the beginning, it looks like it was running a bit faster, and as it started finding bigger inputs, it looks like it might have slowed down a little bit. Although it went from about 850 cases per second to around 780, so it's not a very large change. But that's still something that an analyst might be interested in. The coverage it's been getting over time looks like it started at a coverage of 0 when it had no information. And as it explored the program, it found more and more different blocks, and it's been stuck at around 65 for a while, it looks like. And also how many crashes it's found. It hasn't found any crash yet, so we can't see anything here. And for all of these graphs, it's also viewable as a log scale. Another interesting view is the control flow graph. So this basically acts on the binary, so these are all the functions in the binary, and this now colors all the nodes that have been hit based on the coverage information. So the start function is the entry point of the program. We can see that every part of it has been colored in green now because they've been hit. If you look at the main function, this represents basically what we saw in the source code. We can see that the fuzzer has now gotten through a good bit of the main function, so it has passed the first few if checks with the brute forcing it's doing, but it has not gotten through everything yet where the crashes. So a human analyst might at this point see, okay, maybe I can modify the fuzzer in a way to specifically focus on what this might be looking for to go further. And looks like the coverage has gone from 64 to 65, 66 since we've started running it. Hasn't quite found the crash yet, but if we let it run for a few more minutes, it would find the crash. But yeah, that's pretty much our application. Yeah. Maybe. Oh, it actually just found the crash.
And as we can see, the unique crash is there, just populated to 1. So if we return back to the line graph, maybe the line graph is being a little slow to show its update. But let's go to the control flow graph and show that May now should be all colored in. Yeah, as we can see, those bottom 2 blocks that before weren't are now green, as we did successfully achieve that, did reach that logical block of execution. So with this sort of, as Gilbert was saying, sums up our project in whole. We hope you guys enjoyed looking at it, because we certainly enjoyed working on it mostly throughout the whole semester. Thank you for your time.
Thank you.